Okay, so in problem 26, once we get to this step, we know that a radical cannot be equal to a negative sign, so it's an empty set, no solution. Problem 28. First thing we do is subtract 18 from both sides. Now we divide both sides by 2. Now we raise both sides to the third power because the radical and the exponent cancel each other out. And we subtract 5 and see that y equals 3. Problem 30. Six to the 3x minus 6 power equals 216. The first thing we do is see if we can rewrite 216 as a power of 6. And we recognize that 216 can be written as 6 to the third power. So then our bases cancel and our exponents form the equation. 3x equals 9, x equals 3. Problem 32. Seven to the x minus 1 power equals 1 over 81. Okay, we recognize that 27 and 81 are both multiples of 3. 27 is 3 to the third power. Hold on, let's rewrite that. 27 is 3 to the third power. And 81 is 3 to the fourth power, okay? We can get this out of the denominator by making our exponent negative. Now we cancel our bases, and we have 3 times x minus 1 equals negative 4. 3x minus 3 equals negative 4. We add 3 to both sides. 3x equals negative 1, and x equals negative 1/3. Problem 34. 3 raised to the x plus 6 power equals 243. Again, first thing we want to do is see if 243 can be represented as 3 to a power, and it can. It's 3 to the 5th power. So again, our bases cancel, and we make an equation from our exponents, and we see that x equals negative 1. Problem 36. X times 2 plus the square root of 3 plus 4 equals 7 plus 6 times the square root of 3. First thing we want to do is subtract 4 from both sides, and we see that x times 2 plus the square root of 3 equals 3 plus 6 times the square root of 3. Then we can divide both sides by 2 plus the square root of 3. So now we have x equals 3 plus 6 to the square root of 3 over 2 plus the square root of 3, which requires rationalizing our denominator by multiplying by a conjugate. Once we do that in our denominator, we're going to have 4 minus 9 minus the square root of 9, which will become 4 minus 3, which will become a denominator of 1. And in our numerator, we have to do FOIL. First times first gives us 6. Outer times outer gives us -3 square root of 3. Inner times inner gives us +12 square root of 3. And last times last gives us -6 square root of 9. Okay? When we simplify this, we have 6. This is -6 times 3, so it's -18. 6 and -18 make a -12. We combine these and we get +8 to the square root of 3. All that's over 1. Now that should be +9 to the square root of 3, sorry. All that's over 1. So basically, this is what x equals. -12 plus 9 to the square root of 3. Okay, now for problem 38. Four times 8y minus 5 to the 0.5 power plus 2 times 8y minus 5 to the 0.5 power equal 18. Because these two are identical and their exponents are identical, we can add them together and we get 6 times the 8y minus 5 to the 0.5 power. Now let's divide both sides by 6, and we'll have 8y minus 5 raised to the 0.5 power equal to 3. How do we get rid of this? We raise everything to the second power, and those cancel, because it would have been like saying 1/2 times 2.1. So now we have 8y minus 5 equals 9. We add 5 to both sides. 8y equals 14. So y equals 7/4. Problem 40 is 4 to the 2x minus 5 power equals 32. We begin by seeing how we can simplify 4 and 32. We recognize that 4 is a power of 2, and 32 is also a power of 2. So once again, our bases cancel, and we're left with our exponents for our equation. 4x equals 15, x equals 15/4. And problem 42, which was our final problem in this lesson. 25 to the 3x power equals 625. 625 happens to be 25 squared. If we didn't know that, though, we definitely could break it down to a base of 5. When these cancel, we have 3x equals 2, and x equals 2/3. And we're done with 7.6. Now 7.7, we'll take it up tomorrow, and it will be about more radical equations. So it will build on everything we did in this lesson.